Good day. This is the sub-article presentation of ISAURO Angelo S. Robles, which focuses on measurement of VOCs in ripening stage of Persea Americana fruit using sensor array via Raspberry Pi. For the background of the topic, the researcher first identified the needed data, and that is the Persea Americana or avocado for measurement of VOCs. The Persea Americana is a fruit that has an ethylene compound to determine the ripeness stage, and not using the sense of sight of a person. In today's modern world, newly and advanced technology has arisen and offered alternative way, especially in grading fruits based on fruit's aroma. With this, the researcher uses the so-called electronic nose or e-nose, which is a modern tool rather than using the traditional way of observing and touching the fruit. The researcher needed to answer the main objective of this study, which is to determine the ripeness stage of the avocado fruits using the fuzzy logic classification in MATLAB. Also, there are supporting objectives that to be followed. First, to develop an electronic nose that would measure various VOCs in Persea Americana fruits. Second, to investigate the data reading in each gas sensor, depending on the ripening stage level. The significance of the study will benefit the future works and other researchers for the development of studying the ripeness stage of other fruits. For the methodology, the researcher uses the creation of e-nose for its main flowchart. First, we will create a schematic design for the electronic nose. Second, assembling gas sensors. Next, the connection of ADC module, where the ADC module is replaced by Arduino Nano. Then lastly, the connection of electronic nose to the Raspberry Pi. For this slide, this is the overall view of the prototype. The first picture represents the front view of the prototype where the gas sensor array is mounted at the top of the chamber. Then the second picture represents as the back view of the prototype where the Raspberry Pi is located. For this slide, naming of gas sensor will proceed. First, the MQ2 for the combustible gases, MQ3 for the detection of alcohol, MQ8 for the detection of hydrogen gas, MQ135 for the detection of ammonia, MQ136 for the hydrogen sulfide, TGS822 for detection of ethanol. Lastly, TGS2600 for the gaseous air contaminants. This is the graphical user interface, which shows the data of each gas sensors and consists of 7 boxes which represent as the number of gas sensors in an array, while the last box is the data of temperature sensor. Below it is the result or the interpretation of data. The timer will indicate the execution time, and when it reaches the 300-second mark, the result will be shown. This is the table for the data presentation of the samples. The researchers gathers 50 samples of different fruits with higher number of avocado. This is to be tested in each gas sensors, excluding the 9 samples because there are no changes occurred that makes the data unreliable. For the interpretation of data, the researcher uses the bar graph. The first graph is for the unknown result, where the level of the graph in MQ2, MQ135, and TGS2600 sensors do not exceed the 0.44 barrier. Then the second graph contains the result of an unripe avocado, where the level of amount of TGS822 does not exceed the 0.44 barrier. It means that the ethylene amount of the sample is smaller than the average amount of an unripe avocado. Compared to the first graph, the MQ3, MQ2, MQ8, and MQ136 did pass the 0.44 barrier. The third graph shows the maintaining value for a ripe avocado where there is a hit in the 0.44 barrier in terms of ethylene content, while the other gas sensors increase but with an ample amount to medium amount only. And lastly, compared to the other graphs, there is an increase of large amount in the level of gas reading on each gas sensors, especially the hydrogen and hydrogen sulfide, which indicates that the avocado is overripe or damaged. For the conclusion, based on the gathered data, the researchers were able to conclude that the aroma of the fruit samples for overripe has increased ethylene and other VOCs compared to fruit samples unripe and ripe. Moreover, the use of electronic nose system, the researchers were able to re-engineer conventional method of diagnosing ripening values of chemical imbalances reflected on the fruit aroma. The researcher found out that the test is 82% successful, where 41 out of 50 samples came out with a good result. That's all. Thank you.